In this video, we're going to learn how we can evaluate the sine, the cos, the tan of special angles. So we're looking at the concept of special angles. So let us quickly take a look at this board, and then you would notice that I've got certain diagrams here. This triangle is an equilateral triangle. Are you following? So all sides are equal to 2 units. You can see 1, 1 here is because this perpendicular had been dropped down. The perpendicular has been dropped down to divide the base into 2 equal parts. So you get 1, 1. This angle is 60, 60. This is 30, 30. Actually 60, 60, 60, but we've divided this angle into 2, making it 30, 30. If we use Pythagoras theorem, being that this from the middle here to this is 1, and this is the hypotenuse, which is 2, you know that this is right angle triangle. Take note. Half of this equilateral triangle is right angle triangle. So if you extract the right angle triangle with these 2 and 1, using Pythagoras theorem, you would get this perpendicular height to be root 3. So you need to have this diagram upstairs in mind. Is that okay? This is used for 45 degrees. Okay? For 45 degrees, we use this right angle triangle. Is that okay? So this is 1, this is 1. Then by Pythagoras theorem, this will be root 2. Having stated this, we now want to look at this diagram, which I call my generator. This diagram generated this table. This diagram generated these special angles, which exist in the 4 quadrants, first, second, third, and fourth quadrant. The first values are all in first quadrant, the second is second quadrant, the third row in the third quadrant, and all values in the fourth rows are found in the fourth quadrant. All of these are generated from this diagram. This diagram is just like it's a plane, are you following, right? XY plane, so our cardinal point. We know that this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, back to 360 degrees. Starting from 0, if you start adding 90, 90, 90, you would get the 4 major cardinal operational angles. That's what I call them. Once again, the 4 major cardinal operational angles. Starting from 0, we have 90, we have 180, we have 270, and we have 360. 90 and 270 are on the vertical. And remember, according to the complex plane diagram or Gantt diagram, the vertical, we assign it imaginary, and also the imaginary axis. Then the horizontal, we have 180 and 360 degrees or 0. Please put this down. 180 and 360 degrees. I refer to them as the powerful operational cardinal angles. The reason for that is because the horizontal is the real axis, you know, when dealing with the Gantt diagram, the real axis. So numbers there actually are powerful, which is 180 and 360. You will understand what I mean by that when I start explaining what we have on this part of the board. What do you need to know as a student that is preparing possibly for an exam? Let's assume you're not allowed to use calculator, and then you encounter questions where you have special angles. Of course, in a situation where you're not allowed to use calculator or even 4-figure table, then any question given an angle there is expected, yes, as a right of the student. The examiner setting that question is expected to set the question based on special angles as much as possible. Because for special angles, we can actually obtain their values without calculator, without 4-figure table. Once we have this diagram, our problem is solved. And this diagram can be memorized easily. It's not tough. Does that make sense? So first of all, let us see how we generated these special angles from each of the quadrants. All I need is 15 and 30 degrees. 15 and 30 degrees. So let us see, we have our 0. 0, the first one is 30 degrees, which is adding 30 to this 0. Are you getting me right? You get 30 degrees. How do we now get 45? You add 15 to 30, you get 45, which is the middle. You can see this. Half of each of the quadrants is like adding 45, 45, 45 to the cardinal operational angles, or the operational cardinal angles. Is that okay? If you add 45 to 0, you get the middle of 0 and 90. If you add 45 to 90, you get the middle of 90 and 180, which is there about 135. Are you following? Good. So if I add 30 to this 0, I will get 30 degrees. Add 15 to 30, you get 45. So that's how I got this. Add 15 to that 45, you will get 60, 60, 60. That's how I got this 60. Then add 30 to the 60, you will get 90 degrees. So do you see the movement? 30, 15, 15, 30. 30, 15, 15, 30. That's how I generated this. So coming to this diagram, we are also going to move there about 30, 15, 15, 30. If you add 30 to this 90, you are going to get 120. So between this 90 and 135, we have 120. Once you add 30, the next addition will be what? 15, 15 before 30. Now, add 15 to 120 you have here, you will get 135. Add 15 to 135, you get 150. Then the next addition will be adding 30 to 150, you get 180. Are you following, right? The next move would be again, add 30 to 180, you get 210. After the first 30 addition, you get 210. The next is to add what? 15, 15. Add 15 to 210, you get 225. So you see how the thing moves. Add 15 again to 225, you get 240. Then coming to this, from that 240, add 30, you now get what? 270 degrees. Did you take note of how I moved? Now I'm going to show you my generator here. This is my generator. Look at it. So the idea is from the operational cardinal points 0, 90, 180, 270. Start by adding what? 30. You get another special angle, then 15 under special angle, 15 under special angle, then finally what? 30. The angle closest, the special angle closest to the operational cardinal angles, what you add to them is 30, 30. Then the two in between the angles closest to the operational cardinal angles, the other two angles between them, you add what? 15, 15. Does that make sense? For example, when I got the first 30 here to get 45, I added 15. From 45, you get 60, which is actually 45 plus 15, you get 60. Then from 60 to 30, you add, from 60 to 90 rather, you add 30. Once again, take a look, my generator. Alright? So this is how we actually got the operational cardinal points actually generated the special angles we have here. These first row are all found in the first quadrant. This second row, the angles they are all found in the second quadrant. The third, all the angles they are found in the third quadrant. And these special angles, all of them in the fourth row, are found in the fourth quadrant. Does that make sense? Alright, now let us move on to see how we now generated this value. Please, until we chose to work on the generator of the value of 0 and 90, that is sin 0 cos 0 tan 0, sin 90 cos 90 tan 90. In subsequent videos, we're going to work on that and just show you, just for knowledge sake. For now, memorize them very well, that of 0 degrees and 90 degrees. For 30, 45, and 60 degrees, you extract them from this diagram. Their values are gotten from this diagram. So all you need to do for us is to memorize this table. Now somebody might wonder, how do I memorize this table? It's simple. All you need is having this diagram in mind. Alright, because that's where we obtain these values. For example, sin 60. Sin 60, you come here, so opposite over what? Hypotenuse. This is 60, this is the opposite, root 3, hypotenuse is 2. So sin 60 is simply root 3 over what? 2. You can say that. Sin 60, root 3 over what? 2. What about something like sin 30? You will come to this is your 30, so opposite over hypotenuse. So sin 30 is 1 over 2. You can say that sin 30, 1 over 2. You want to get something like cos 45. You come to this diagram, because that's where you have the 45. Cos is car, adjacent over what? Hypotenuse. So 45, any one of them. If I choose this, the adjacent is 1. Car, adjacent over what? Hypotenuse. So cos 45 is actually 1 over root 2. Cos 45, 1 over root 2. Can we quickly check for tan 30 and see. Tan 30, I will come to this diagram. This is 30 degrees. Tan, TOA, opposite over adjacent. So this is 30, tan 30 opposite over adjacent, which means that tan 30 is actually 1 over root 3. Tan 30, 1 over root what? 3. From this, we can generate the value of every other special angle here. In subsequent videos, we are going to generate them completely, make a full table, and then upload. So please, make sure you visit our YouTube channel at GMAS41, subscribe, and please turn on the notification bell so that when we upload the video on the full table of these special angles, you'll be the first to receive a notification on it. Alright, now let us look at how it goes. I want us to see how to get the value of special angles in the second quadrant, in the third quadrant, and in the fourth quadrant. Is that okay? At this point, the power of 180 degrees and 360 degrees. Please put this down. Every special angle in the second and third quadrant is subject to the power of 180 degrees. Write this down, please. Every angle in the second and third quadrant is subject to the power of 180 degrees, which means from 180 degrees you can get their values. Then every special angle in the fourth quadrant is subject to the power of 360 degrees. What do I mean by that? Let us find out. I'm going to get the value of sine, cos, and tan for each of the angles in the second, third, and fourth quadrant. These ones already we have their values here. So let us find out the value of something like sine 120. How do I get the value of sine 120? I even have it here. I'm taking an examination where I'm not allowed to use calculator. 120 is in the second quadrant, so it is subject to the power of what? 180 degrees. Because 120 is not up to 180 degrees, this is what I would do. Subject the 120 to the power of 180. So this is equal to sine 180 minus, because 120 is less than 180, you subtract it from 180. Therefore, sine 120 is equivalent to sine 60. It's equivalent to sine 60. And the value of sine 60 is what? Sine 60 is root 3 over 2. At least you have this already at heart, you know, because I've advised you to memorize this table. It's not difficult. It comes from this diagram. Is that okay? It comes from here. So even if you can't memorize this one. This diagram from there generates the values. Is that okay? Now, do you now see that sine 120 will be equivalent to sine 60? As a result of having subjected 120 to the power of 180 degrees. Are you seeing that now, right? And I know the value of sine 60 to be root 3 over 2. Therefore, sine 120 is also what? Root 3 over 2. Root 3 over 2. So you see how we obtain that. Take note that 120 is in the second quadrant. Sine in the second quadrant is positive. So we are okay. In the first quadrant, all the trig functions, the basic trig functions, sine, cos, and tan, are all positive. In the second quadrant, only sine is positive. It means if you are obtaining cos or tan of any angle in the first quadrant, it's going to be negative. Only sine will be positive. In the third quadrant, only tan is positive. So if you want to get the sine or the cos of any angle in the third quadrant, the value is going to be negative. Then in the fourth quadrant, only cos is positive. Therefore, if you want to evaluate the sine or the tan of any angle in the fourth quadrant, your result is going to be what? Negative, being that only cos is positive there. Alright, now we are done with this. Can we obtain the value of cos 120 now? Cos 120 and tan 120. We have seen that of sine 120. So let's go. Cos 120 will now be equivalent to cos, remember you're subjecting it to the power of 180 degrees, which means that cos 120 will be equal to cos 60 degrees. So let us find out. Cos 60, what's the value? Cos 60 is 1 over 2. Cos 60 is 1 over 2, which is 0.5. It simply means that cos 120 is also equivalent to what? Cos 60. Therefore, cos 120 would give us this 1 over 2. But we want to check what is the sign of cos in the second quadrant. Because 120 is in the second quadrant. Are you following, right? Cos in the second quadrant is negative. Therefore, cos 120 will be equal to negative of cos 60. Are you following? Cos 120 will be equal to negative, let me indicate it, of cos 60. So once you obtain cos 60 degrees, put minus. Are you following, right? That will give you the value of cos 120 degrees. I hope you see how 180 is working out in for us. Okay, let us find out this. Let's find out tan. Let's say tan. I've used 120 too much. What do you think? So why don't we try tan 135? Tan 135. Once again, 135 is in the second quadrant, so it is subject to the power of 180. 135 is less than 180, so you subtract it from 180 to get the equivalent. This would be, okay, first of all, let's work out something. Let's identify the quadrant of this number. It's in the second quadrant. Tan there is negative. So this is going to be minus tan, open bracket, 180 minus 135. And then tan 135 will now be equal to negative of anything you get from tan 180 minus 135. 180 minus 135 is 45, we know that, is that not so? So do you see that tan 135, I don't know the value because it's not here in my table. But I've been able to convert it to tan 45 because they're equivalent. So I will find tan 45, anything I get, negative of it is equivalent to tan 135. So tan 45 is 1. Therefore, tan 135 will be minus 1. Alright, we are done with angles in the second quadrant. Can we move on to see how we can get values of angles in the third quadrant? Again, remember the third quadrant is subject to the power of 180 degrees. So let us just find for 1, okay? Can we check for, let's say 240. Let's check for 240 and see. Okay, so sine 240. How do I get a value? All I will need to do is to subtract 180 from this 240. Or I will ask myself, which number will I add to 180 to get 240? Because 240 is in this third quadrant. But I prefer going by the subtraction format. 180 is less than 240, so you subtract it. It's going to be, but let's find out, sine in the third quadrant is negative. I hope you know, because it's only tan that is positive there. So it's going to be minus of sine 240 minus 180. Are you following, right? So this is what it's going to be. Minus sine 240 minus 180. So that sine 240 will now be equal to minus sine 240 minus 180 will give us 240 minus 180 will give us 60. Will give us 60. So do you see that sine 240 is negative sine 60. Sine 60 we know it to be root 3 over 2. Therefore, sine 140 will be equal to minus root 3 over 2. Okay, let us try 1 again. Let's try 1 there. Alright. Let us look at the value of cos 210. Cos 210. I don't know the value of that, so what do? I'll convert it to the angle of the first quadrant. 210 is in the second quadrant. Cos there is negative because it's only tan that is positive there. So I am going to subject it. I'll put minus of cos, then I'll subject 210 to the power of 180. Since 210 is more than 180, I'll do 210 minus 180. Then cos 210 will now be equivalent to minus cos. Now let us see, 210 minus 180, what would we get? 210 minus 180 is 0, 0. Let's find out. Then because that's going to give us 30. So do you see that cos 210 is minus the value of cos 30? Let's find out what is cos 30. Cos 30 is 1 over root 3. Therefore, cos 210 will be minus 1 over root 3. I hope this is making sense, right? So you see that actually you can do a lot of things on special angle without calculator. Just have this diagram. That's the secret to everything. Let's round off now by looking at an angle in the fourth quadrant. An angle in the first quadrant. An angle in the fourth quadrant. Which one would we pick? Should we do 315? Let's work on that and see. So, let me do tan 315. How would I get the result? I'll look at this. 315 is in the fourth quadrant. Tan here is negative. So that is going to be minus tan. Take note that 315 is in the fourth quadrant now. So it will be subject to the power of 360 degrees. And because 315 is less than 360 degrees, it's going to be 360 minus 315. Therefore, tan 315 will still give me the same result as minus tan 360 minus 315 will give us 45. Good. So do you see how I converted it to an angle in the first quadrant? Tan 45, you can obtain it. The value of tan 45 is 1. Therefore, tan 315 will be minus 1. Tan 315 will be minus 1. Does that make sense? Alright. Can we round off with evaluating cos 315 there? Cos 315. Cos 315 will be equal to, once again, 315 is in what quadrant? It's in the fourth quadrant, and there cos is already positive, so the result we're going to get here is positive. But I have to convert this 315 to an angle in the first quadrant so I can easily get a value. So this is cos, you subject it to the power of 360. 360 minus 315. And so you see that cos 315 is equal to cos 45. Good. Cos 45, you can evaluate it from here, is 1 over root 2. It simply means that cos 315 is also 1 over root 2. So that is all. Please watch this video, play it over and over again. Write out certain important key facts that I mentioned, and I also encouraged you to write it down so that you would not forget easily. Don't forget the power of 180 degrees and 360. 180 degrees operates over any special angle in second and third quadrant, and then 360 degrees operate over any special angle in the fourth quadrant. Don't forget, in the first quadrant, sine, cos, and tan are positive. In the second quadrant, only sine is positive. Therefore, cos, tan are negative in the second quadrant. Third quadrant, only tan is positive. Therefore, cos and sine are negative there. In the fourth quadrant, only cos is positive. Therefore, sine and tan are negative. Remember to memorize this diagram, this equilateral triangle and right angle triangle for 45 degrees and for 60 degrees. Your problem would have been solved. In conclusion also, remember how these special angles are generated. Starting from 0, we've got 30, 15, 15, 30. What you are adding up, which gives us 0, 30, 45, 60, 90. Again, from that 90 you move on, 30, 15, 15, 30. From 90, 30 added is 120. Then 15 added to 120 is going to give you 135. 15 added to 135 will give us 150. 30 added to 150 lands us to 180. Then you continue. Please, these are key words, facts to note down.